Harvard astrophysicist Avi Loeb has just published a controversial analysis claiming the interstellar object 3I, Atlas, is broadcasting signals in the exact frequencies SETI monitors for alien contact. The detection sits at 1.665 and 1.667 gigahertz, right in the protected waterhole band where intelligent civilizations would transmit. The evidence is real. The data is confirmed. The implications are staggering. Loeb's calculations show this alignment has only a 1 in 10,000 chance of happening naturally. Think about that. A visitor from another star system arrives broadcasting in the precise frequencies we've been watching for decades. The same quiet electromagnetic window Carl Sagan called humanity's cosmic listening post. And this object isn't behaving like any comet we've seen. Every single day, an invisible force pushes 3I, Atlas, further off course. Not from the sun's gravity, not from solar wind, something else entirely. The acceleration reaches 135 kilometers per day squared. That's enough power to deflect the object thousands of kilometers beyond where physics says it should be. The numbers don't lie. At the same time, this thing is hemorrhaging mass like a collapsing skyscraper. Loeb's analysis shows it's shedding at least 33 billion tons of material city blocks worth of mass, breaking apart in slow motion. Every second, it loses weight, equal to an entire SUV. Even while sitting 3.5 astronomical units from the Sunday, that's past Mars, where comets stay frozen and quiet, but 3I, Atlas, burns. What makes Loeb's claim so explosive is the timing. The South African Radio Astronomy Observatory's MeerKAT telescope detected hydroxyl absorption lines from the object on October 24th. Those specific frequencies, 1.665 and 1.667 gigahertz, sit dead center in the waterhole. The electromagnetic sweet spot between hydrogen and hydroxyl emissions, where background noise drops to almost nothing. SETI has monitored this band for 60 years. Now, an interstellar visitor broadcasts there. Loeb frames this as more than coincidence. His July 16th paper to the scientific community laid out the mathematical case. The non-gravitational acceleration can't be explained by normal outgassing. The trajectory doesn't match ice sublimation patterns. The fragmentation looks engineered, not natural. And now, the radio emissions land exactly where an intelligent signal would hide. The mainstream scientific community calls this speculation. But Loeb has the credentials to make these claims. Former chair of Harvard's astronomy department, published over 800 peer-reviewed papers, led the Black Hole Initiative. His voice carries weight in astrophysics. When he says something doesn't add up, people listen, even if they disagree. Here's what we know for certain. On July 1st, 2025, the Atlas telescope in Chile spotted a new object. Initial observations showed a hyperbolic orbit, the mathematical signature of something from outside our solar system. Only the third confirmed interstellar object after Oumuamua and Borisov. The Minor Planet Center designated it C 2024 S1, later renamed 3I, Atlas, when its interstellar origin was confirmed. The object came screaming in at 68 kilometers per second, faster than any bullet. That velocity alone tells us it originated far beyond our sun's influence. Probably ejected from another star system millions of years ago, now passing through our neighborhood on a one-way journey back to interstellar space. NASA's Jet Propulsion Laboratory started tracking immediately. Engineer David Farnokia noticed something strange in the navigation data. The object wasn't following a pure gravitational path. Something was pushing it, creating what scientists call non-gravitational acceleration. Comets do this naturally. Ice heats up near the Sunday, turns to gas. Jets form, push the comet like tiny rockets. We've seen it hundreds of times. Standard comet behavior, nothing mysterious. But 3I, Atlas, pushes differently. The acceleration has two components. A radial push directly away from the sun, 135 kilometers per day squared, plus a transverse component 60 kilometers per day squared, pushing sideways to its orbit. That sideways push is what caught Loeb's attention. It suggests directional control, steering, not random outgassing. Think about what that means. If jets of gas cause the push, they should be visible. Hubble should see them. James Webb should detect the heat signatures. Ground telescopes should capture the reflected sunlight off ejected dust and ice. We have the technology. We're watching closely. Yet the images show something unexpected. Where astronomers expect to see a bright coma, the glowing cloud of gas around a comet's nucleus, 3I, Atlas, stays dark. Where they expect a tail streaming away from the sun, the object shows an anti-tail, pointing toward the Sunday backwards, like the object is firing thrusters in reverse. Loeb calculates the mass loss required to generate this acceleration. His numbers are staggering. The object would need to shed material equivalent to a 4-mile wide sphere. That's roughly 23 kilometers in diameter, bigger than many asteroids. All that mass converted to thrust. The math works out to 40 kilograms per second at 3.5 AU from the Sunday. That's like vaporizing a car every minute. But here's where the mainstream explanation starts to fall apart. Natural comets don't lose that much mass that far from the Sunday. The solar radiation is too weak, the temperature too cold, ice stays frozen. Yet 3I, Atlas, burns like it's sitting next to a furnace. Loeb points to another anomaly, the fragmentation pattern. Most comets break apart chaotically. Random chunks splitting off as structural weak points fail, like dropping a snowball on concrete. Pieces scatter everywhere. No pattern, no control. 3I Atlas fragmented differently. The object split into what Loeb describes as organized components, not random debris. Structured pieces, like modular segments detaching on schedule. He compares it to staged rocket separation. Controlled, purposeful, engineered. That's not a natural process. The timing makes it stranger. The fragmentation occurred as the object approached perihelion, its closest point to the Sunday, right? When you'd expect maximum stress on the structure, but also right when you'd want to shed mass, if you were trying to alter trajectory, to steer, to aim, to target. Ki-Chung Jung from Lowell Observatory disagrees completely. He published observations showing standard comet chemistry, water, carbon monoxide, carbon dioxide, methanol, the usual suspects. Nothing exotic, nothing artificial, just frozen gases doing what frozen gases do near stars. Sublimating. Zhang's team used spectroscopy to analyze light from 3I Atlas. Different molecules absorb specific wavelengths, create fingerprints in the spectrum. Their data shows typical comet composition, a dirty snowball from another star system. Interesting for being interstellar, not interesting for being artificial. The spectroscopic evidence is solid. But Loeb asks a different question. What if something artificial was designed to look natural, to mimic comet chemistry while hiding its true nature? A camouflage of ice and dust over an engineered core? We'd see exactly what we're seeing now. Natural signatures on the surface. Anomalous behavior underneath. That's where the radio detection becomes critical. Richard Cloete's team at MeerKAT wasn't looking for aliens. They were studying comet chemistry, looking for hydroxyl radicals, OH molecules that form when ultraviolet light breaks apart water molecules. Standard astronomy, routine observation. They found the hydroxyl, right, at 1.665 and 1.667 gigahertz. Cloete interprets this as natural water chemistry. Photodissociation creating OH radicals that absorb background radiation at specific frequencies. Happens with every comet. Nothing special. Just molecules doing what molecules do. Loeb sees it differently. Those exact frequencies sit in the water hole. The cosmic quiet zone between 1.42 gigahertz, the hydrogen line, and 1.666 gigahertz, the hydroxyl line. For 60 years, SETI has argued any intelligent civilization would broadcast here. Minimum interference, maximum range. The galactic phone line, and now 3I Atlas calls. The probability matters. Hydroxyl can absorb at multiple frequencies depending on molecular rotation and vibration states. The chance of hitting those exact SETI frequencies by accident? Loeb calculates 1 in 10,000. Not impossible, but improbable enough to raise questions, especially given everything else. The acceleration, the fragmentation, the anti-tail, the mass loss, the radio frequency. Each piece alone has a natural explanation. Together they paint a different picture, a pattern that suggests intention, design, purpose. But that's where the scientific method demands caution. Extraordinary claims require extraordinary evidence. Saying an interstellar object might be artificial isn't just bold, it's career-defining or career-ending. Depends on what future observations reveal. That's why December 19th, 2025 matters so much. On that date, 3I, Atlas, makes its closest approach to Earth. Still 269 million kilometers away, nearly twice the distance to the Sunday, but close enough for our best telescopes to see details, to resolve the nucleus, to detect faint jets, to measure composition precisely. If the object develops a normal comet tail by then, the natural explanation wins. If it stays anomalous, questions multiply. Darrell Seligman from Michigan State University published calculations showing how carbon monoxide jets could explain everything. CO sublimates at much lower temperatures than water ice, stays active far from the Sunday, creates thrust without visible tails. His models match 3I, Atlas's behavior using pure physics. No aliens required. The scientific community largely agrees with Seligman, but agreement isn't proof. Science advances through skepticism, through questioning accepted explanations, through scientists like Loeb willing to risk reputation on controversial hypotheses, especially when those hypotheses challenge orthodoxy. Consider what we're really debating. An object from another star system enters our solar system, shows unusual acceleration. Fragments in an organized pattern, broadcasts on frequencies, SETI monitors, and does all this while disguised as a normal comet. Either nature created the perfect coincidence, or something else is happening. The MeerKAT data adds another layer. The radio telescope detected absorption lines, not emissions. The object isn't broadcasting, it's absorbing background radiation at specific frequencies, like a cosmic barcode, a signature, an identifier. Natural? Maybe. Intentional? Possibly. The frustration comes from our limitations. We can't send a probe to intercept 3I Atlas. Too far. Too fast. Moving at 68 kilometers per second, it would take our fastest spacecraft decades to catch up. By then, it'll be halfway to the next star. We can only watch and calculate and argue. James Webb Space Telescope observed 3I Atlas in infrared, looking for heat signatures from the nucleus, trying to measure size and composition. The data shows a body at least several kilometers wide, covered in organic molecules, tholins, the red-brown gunk that forms when cosmic rays hit simple carbon compounds. Standard interstellar object composition. But Webb also detected something unusual. Temperature variations across the surface that don't match solar heating patterns. Hot spots where there should be cold zones facing the Sunday, like internal heat sources, or active machinery, or just weird ice chemistry we don't understand yet. Pick your explanation. Each new observation adds data without resolving the fundamental question. Is 3I Atlas natural or artificial? The evidence splits down the middle. Half points one way, half the other. Scientists divide into camps. Traditionalists versus revolutionaries. Conservatives versus speculators. Loeb stands almost alone, suggesting artificial origin, but standing alone doesn't mean being wrong. History's filled with lone scientists proposing radical ideas. Continental drift, quantum mechanics, relativity, all started with one person seeing patterns, others missed or refused to see. Sometimes the outlier is just wrong, sometimes they're decades ahead. Time reveals which, for 3I Atlas, That time approaches quickly. March 16th, 2026. The object passes within 53 million kilometers of Jupiter. NASA's Juno spacecraft, already orbiting the gas giant, will attempt radio detection, looking for transmissions, signals, anything artificial. If Juno detects structured radio emissions, everything changes. If it detects nothing, Loeb's hypothesis weakens. But absence of evidence isn't evidence of absence. An artificial object might stay radio silent, might transmit on frequencies. Juno can't detect, might have already completed its mission. The possibilities multiply faster than our ability to test them. That's what makes this so maddening and so important. We're potentially witnessing first contact. Not the Hollywood version with giant ships over cities. Something subtler, a probe disguised as natural phenomenon, testing our detection capabilities, seeing if we're smart enough to notice, advanced enough to understand. Or we're witnessing a weird comet. The societal implications depend entirely on which interpretation proves correct. If artificial, it confirms we're not alone, that intelligence exists elsewhere, that interstellar travel is possible, that someone or something sent a messenger to our system. Humanity's perspective shifts forever. If natural, we learn about interstellar objects, how other solar systems form, what chemistry exists in deep space, valuable science, important discoveries, but not paradigm-shattering. The stakes couldn't be higher. That's why Loeb's analysis matters even if he's wrong. By forcing the conversation, by demanding we look closer, by refusing to accept easy explanations when data doesn't quite fit. Science needs skeptics, especially credentialed skeptics willing to risk reputation on unpopular ideas. Because sometimes unpopular ideas are right. The waterhole frequencies keep nagging. Of all the places in the electromagnetic spectrum, why there? Hydroxyl absorption happens at many frequencies. The molecular transitions create multiple absorption lines. Most fall outside the waterhole. But 3I Atlas hits the bullseye. Coincidence has limits. At some point, enough coincidences become a pattern. Enough anomalies become evidence. Enough questions demand new answers. Loeb argues we've reached that point with 3I Atlas. The mainstream disagrees. But disagreement is how science advances. Through conflict, through debate, through data. The next few weeks will provide crucial observations. Every major telescope on Earth and in space is watching 3I Atlas, measuring, recording, analyzing, looking for the definitive evidence that settles the debate, the smoking gun, the proof, natural or artificial, comet or craft, visitor or vehicle. NASA's Deep Space Network listens continuously. If 3I Atlas transmits anything, even a single structured pulse will detect it. The Very Large Array in New Mexico sweeps multiple frequencies. The Parkes Observatory in Australia monitors southern sky approaches. Arecibo would have watched too, if it hadn't collapsed. We're throwing everything at this object, because we might not get another chance. Interstellar objects are rare. Only 3 confirmed in human history. Oumuamua in 2017, Borisov in 2019, now 3I Atlas in 2025. Each one teaches us something new. Each one raises more questions than answers, but this one's different. This one's broadcasting intentionally or not on frequencies we've been monitoring for signals from extraterrestrial intelligence. This one's accelerating in ways that challenge our models. This one's fragmenting in patterns that look purposeful. This one makes us wonder. The December 19th observations will show if 3I Atlas develops the bright coma expected from its calculated mass loss. 40 kilograms per second should create a visible cloud of gas and dust. Telescopes should see it easily at closest approach. If that coma appears, it supports natural outgassing. If it doesn't appear, we have a problem. Physics demands that mass loss creates visible ejecta. You can't accelerate an object without throwing mass in the opposite direction. Newton's third law, action and reaction. If 3 Atlas accelerates without visible mass loss, it suggests something else, something that doesn't require reaction mass, something engineered. Loeb carefully avoids saying alien spacecraft. He frames his analysis as questions, not conclusions, as possibilities worth investigating, not facts to accept. He practices good science, following data, testing hypotheses, remaining skeptical even of his own ideas, but the implications lurk beneath every calculation. If 3I Atlas is artificial, who sent it? When did they send it? Why did they send it? How long has it been traveling? Where is it going next? What is its purpose? The questions cascade endlessly, each one more profound than the last, and we may never know the answers. Even if we confirm artificial origin, that doesn't tell us intent. A probe could be exploratory, scientific, peaceful, or it could be reconnaissance, surveillance, hostile. We project our assumptions onto cosmic uncertainty, fear and hope in equal measure. The interstellar nature adds complexity. 3I Atlas has been traveling for millions, possibly billions of years. Whoever or whatever sent it might be extinct, their civilization dust, their star dead. We might be examining an ancient artifact from a ghost culture, a message in a bottle from a dead ocean, or they might be thriving, watching, waiting for us to notice their calling card, to respond, to prove we're worth contacting. The technological and intellectual barrier to entry for galactic civilization. Can you spot the probe among the comets? That's the test Loeb suggests we're failing. By dismissing anomalies, by accepting easy explanations, by not looking closely enough at things that don't quite fit. Science requires conservatism, but also courage. The willingness to say this is strange when everyone else says this is normal. 3I Atlas is strange. Even skeptics admit that. The acceleration is higher than most comets. The fragmentation pattern is unusual. The radio frequencies are coincidental at minimum. The anti-tail is hard to explain. Add them together and you get an object worth scrutinizing, which is exactly what's happening. The European Southern Observatory's very large telescope in Chile captures images nightly, looking for rotation patterns, surface features, compositional variations, anything that distinguishes artificial from natural. So far, the results are ambiguous. Could be either. Might be both. That's the most frustrating possibility. What if 3I Atlas is a natural object modified by intelligence? A comet-turned spacecraft, ice and rock with machinery inside, using natural materials as camouflage and fuel. We'd see exactly what we're seeing. Natural signatures hiding artificial purpose, the perfect disguise, or the perfect paranoia, because maybe we're seeing patterns that don't exist. Imposing meaning on randomness, finding intention in chaos. The human brain evolved to detect agency, to see purpose, to assume intent. It's how our ancestors survived, by assuming the rustling bush hid a predator, even when it was just wind. Maybe 3I Atlas is just wind, cosmic wind, natural forces creating unusual but explainable phenomena. Maybe Loeb seeing faces in clouds, patterns in static, meaning in noise. Maybe, but maybe not. The beauty of science is we don't have to guess. We can measure, we can test, we can observe. December 19th brings answers. March 16th brings more. Each observation adds data, constrains possibilities, narrows options. Eventually, truth emerges, whether we like that truth or not. For now, we exist in uncertainty, in the space between natural and artificial, between alone and accompanied, between ordinary and extraordinary. It's an uncomfortable place, but a necessary one. Science lives in uncertainty. thrives on questions, advances through doubt. 3I Atlas embodies that uncertainty. Every astronomer watching knows this could be the moment, the discovery, the confirmation, or just another weird comet adding to our catalog of cosmic oddities. Either outcome advances knowledge, but only one changes civilization. Loeb's betting on change. The scientific establishment's betting on continuity. December 19th starts revealing who's right. The observations scheduled for that date will show if 3I Atlas develops the massive coma its acceleration requires, if jets become visible, if the nucleus matches predictions, if the chemistry stays consistent, or if everything stays anomalous, stay weird, stay questionable. The radio observations continue too. MeerKAT monitors continuously looking for variations in the hydroxyl absorption, patterns, modulations, anything suggesting information encoding. So far it's steady. Constant absorption at those peculiar frequencies. Natural chemistry? Probably. Beacon signature? Possibly. We need more data to know. More time. More observations. More analysis. But time's running out. Every day 3I, Atlas flies further from the Sunday dims, cools, becomes harder to study. We have weeks, maybe months, before it fades beyond detection. Then it's gone forever. Back to interstellar space, carrying its secrets, leaving only questions and arguments that will persist for decades. Did we miss first contact? Did we dismiss evidence? Did we fail the test? Or did we correctly identify a natural object? Science doesn't allow do-overs. We get one chance with each interstellar visitor, one opportunity to gather data, to test hypotheses, to answer fundamental questions. Miss that window and it's gone. No second chances, no replays. That's what makes this moment crucial, and what makes Loeb's voice important, even if he's wrong, especially if he's wrong, because he's forcing us to look harder, to question assumptions, to gather more data, to be absolutely certain we're not missing something profound. The stakes justify paranoia. If there's even a 1% chance 3I ATLAS is artificial, we need to investigate like it's 90%. Because the cost of missing first contact dwarfs the cost of being wrong about a comet. Embarrassment heals. Ignorance is forever. So we watch, we measure, we argue. And on December 19th, 2025, we'll know more. The closest approach will reveal details invisible now. We'll show if Loeb's anomalies persist or dissolve. We'll determine if this story ends with revelation or retraction, natural or artificial. The universe doesn't care about our debates. 3I Atlas is what it is. Our opinions don't change its nature. Only observation reveals truth. And that truth, whatever it is, will be worth knowing. Even if it's disappointing, even if it's extraordinary, the data will decide.